Hello, fabulous fifth graders. Okay, here we are. We're at our last lesson of the year, and we are going to be switching gears completely from all sorts of multiplying and dividing and fractions and decimals, and we're going to be talking about coordinate planes or coordinate grids. So a little bit of geometry to end us off with. It's something fun. There are a lot of unique little games we can play as well, so we figured it was a great way to kind of end our year with a fun lesson. So here we go. So we have just a starter question for you to kind of just get you thinking about what do number lines show? What's the purpose of a number line? We have used number lines throughout the year for a variety of different things, for decimals, for fractions, and what are we always showing with that? And you've been working with number lines probably since kindergarten at this point. And what are they showing? Well, in this example here, the yellow highlighted area is showing a distance between 0 and 5. And different number lines show different distances, but they're always showing locations of something in relationship to where you are. This is a real life practical example that we see quite often is maps, right? Mappings or GPS. So you might not be physically taking out a map, but it's watching your distances. You're always tracking your mileage, your distance, your scales, that sort of thing. So when we're using number lines, we're always jumping up on a number line for multiplying or adding. We're jumping down or regrouping things when we're dividing or subtracting. So number lines are very good for showing growth or decrease in distances, and it helps show location. And that is what we're going to be working on today. Like I said, a little bit of geometry, locations. So this is a coordinate grid, and it's similar to a number line. So hopefully you're kind of thinking about what this looks like in relationship to a number line. It is showing you a number line horizontally, left to right, and it's showing you another number line vertically, up and down. This one is going from 0 to 9, both ways, and so it's just tracking distance horizontally and vertically. So it's very similar to a number line in the fact that it is actually two number lines put together to kind of graph space in between. So what if something's not exactly on one number line but falls in an area on two number lines? And again, a lot of this has to go back to mapping. So coordinate planes are two number lines placed together, one vertically and one horizontally, and they are used to show distance in a given space, as I had already mentioned, particularly in maps. So important facts to know about coordinate planes. There is a horizontal line, the one that goes left to right, and that is called the x-axis. There is a vertical line that goes up and down, and that is called the y-axis. And there's a starting point. There always has to be a starting point, and the starting point is called the origin. Kind of think of it, it looks kind of like the number original, right? It's where your starting point is, and that's located at 0, 0. We'll kind of get into how you read the grids in a few moments, but for now it's the origin and it's located at 0, 0, and it is our starting point. We'll talk about that in a minute. Other things to kind of take note of is we're going to be focusing on it's called a quadrant. Typically, coordinate planes have 4 quadrants or sections, and you can see them labeled in the picture. We're going to be focusing only on that first quadrant. So all of the pictures you're going to see today and as you work this week are going to be zoomed in on that first quadrant. You'll explore the other 3 quadrants more next year. But we're just going to work with the first quadrant, but it's important to know there are 4. And if you're kind of thinking about it, it makes sense because we know that there are positive values and negative values, and they go on number lines as well, right? So it's just taking the negative side and working with those as well on a number line. But for our purposes this year, we're only going to be working with the positive number line section of the coordinate plane, which is called quadrant 1. And I'm just pointing out again, there's the x-axis. Your origin, see, very, very important. It starts at that center location of the whole coordinate grid. And the y-axis is that vertical place. Okay, so a couple of important things to keep in mind when you're reading a coordinate grid. You always slide before you climb, meaning you're always going to move horizontally and then vertically. Kind of you're going to crawl before you walk, right? You're going to walk before you fly, slide before you climb. You're going left or right, and then you're going up and down. Points on the coordinate grid are called ordered pairs because you need to read them in a certain order, and they always come in pairs. Ordered pairs are written in the format x, comma, y in parentheses. You're always writing the x-axis location first, followed by the y-axis location. So you're always going to do the horizontal one first, and then the vertical one gets listed because you're always going to slide before you climb. And they're always grouped in parentheses because making sure they never get separated, right? They're a pair. So they're always in that format. I also remember that they're always going to be in that format because X comes before Y in the alphabet. So another trick. All right, so let's look at some examples of what I'm talking about. So if you look at the locations of the different dots, you're going to see that the ordered pairs below the graph show the exact location of each point. And you'll notice that the pairs are written in the ordered pair format. So the red dot is located at 2, 5. So you can kind of see I had to slide over to the 2 on the x-axis and then climb up to the 5 on the y-axis. And the points are always located at the intersection of the two numbers you're using, the 2 and the 5. It is located in that corner spot, right? The blue one is located at 4, slide 4, and then go up 1, 4, 1. Not to be confused with the green dot, that's at 1, 4. So slide over 1 and then go up 4. Very important. If you're talking to somebody and telling them where something's located, you don't want to tell them 1, 4 when you really mean 4, 1, right? They're very different locations. So it's important that you're always going on your x-axis first, your y-axis second. And the yellow one is located at 5, 6. Okay. Let's look at some other ones. So where's the red star located? So you're going to be starting, you always, always, always start at your origin. That's 0, 0, 0 on the x, 0 on the y. And then slide to the right on your x-axis until you reach the star, just like so. And then you're going to climb up the y-axis until you reach the star, like so. And where have we landed? So we went over and up, and where did we land? Hopefully you are thinking 3, 5. Notice how 3 has to go first, 5 goes second, with a comma in between and parentheses grouping them together. Let's try one more. Where's the blue star located? Well, we're going to slide over on the right until we reach where the star is located, and then we're going to go straight up. And where did we land? Hopefully you are thinking about the pair 6, 7. Okay, and that's really what we're doing here. We're just sliding and climbing, sliding and climbing. So let's look at this graph. Here's kind of a more real world application. So what's this graph showing? It's showing a small town. The circles represent cars, and the rectangles are labeled as particular places in the town: the park, the school, the shopping mall. So looking at the map, which car is closest to the origin? And color it in red. Obviously, you're not going to color it, but you can think about where it is and what's that ordered pair that goes with it. So take a minute, think about it, pause if you need to. We're sliding and climbing. And what is the closest one to the origin? The 0, 0 mark. Hopefully, you are thinking about that spot right there, 3, 2. Okay. let's look at another one. Looking at the map, find the car that is located at 119 and color it green. Again, you're not going to be coloring it green, but find it on the map. Think about it, visualize it, put your finger there. Were you thinking right there? Hopefully you were. Last one, well, I think I have two more actually. The blue car is located closest to the park. Color it blue and tell me its location. So you can't color it blue, but you probably can tell me where it is. Find where the park is, the closest car. And where is that car located? Hopefully you were thinking there. And it is located at, oh, I didn't even write it, 610. 610. Nicely done. And last kind of tidbit, looking at the map, the ordered pair, 1011, tells the location of the corner of one of the buildings. What is the building? And what are the locations of the other three corners of that building? So 1011, where is it? Find it. What building are we talking about? And then what are those other corners of that building? Take a minute, pause if you need to. Hopefully you are thinking. We have 1011. I am also, once I find 1011, I'm looking at 1019. And then I'm sliding over and I'm looking at maybe 811 and 819. And my answer is the shopping mall. And here are those three ordered pairs. That's really all there is to this. It's sliding and climbing and finding where you're going and making sure you are writing your ordered pairs in order. X always comes before Y. The slide always comes before the climb. And making sure you're putting those dots and those intersections as you work through your practice pages this week and your activities this week, as that will become really important, is that you're not just sloshing them anywhere. You're not just putting them in the middle of a square. They go on the corner of the two intersecting pieces that you're talking about. Okay, so that's going to be really important as well. And then the last piece you can kind of think about is distance and how far away things are from each other. So like the school and the park in this example are 2 units away from each other horizontally, right? I would have to walk 2 squares over to get to the school from the park. So I'd have to walk up 2 squares to get to the shopping mall. Depending on where the entrance is, I might have to walk a little bit further than that to the school, right? So kind of just thinking about its locations, its finding where you are, its mapping, its real-world practicality at its finest. It's geometry. It's awesome. Thank you so much for coming. I appreciate it. I know it's June and we're itching to be done, so I appreciate it. Thank you for your time and best of luck as you practice this week. And talk again soon. Thank you.